This brief video is going to talk about how to rationalize a denominator when that denominator has either a radical or a complex number in it. To rationalize something, that means you want to rewrite it so that that denominator is written as a rational number, hence rationalizing. So in general for us, that means that we want no negative numbers down there, no radicals or square roots or any sort of root, and then no non-real numbers or imaginary complex numbers. So as you look at our two examples here, we have 5 over 3 square root of 7 and 10 over 4i. Well, both of those have something that's bad in it. The square root of 7 there, that's definitely bad because there's your radical. Also this I that's down here, that's bad because that's a non-real answer. So let's take a look at this first example. And what we think about is that this denominator right here, it's important to know is that there's only one term. Right, so yeah, it's 3 times square root of 7, but you're not adding or subtracting anything to it. So we say it's only got one term. In those scenarios, in order to rationalize it, it's actually not that bad. You just need to multiply by something that will get rid of the bad part. So this 3 doesn't matter, really. It's there, but it doesn't make it irrational or doesn't make it non-real. It's just square root of 7. So we multiply by the square root of 7. But of course you have to do that on bottom and on top because this is all equal to 1. And so you can multiply by it on top and bottom. And of course a square root of 7 being multiplied by the square root of 7, it's not a distributive property. You just multiply those two things by each other and you get 7 there with that 3 out front still. And then on top you just have 5 square root of 7. And then your final step would just be to simplify. 3 times 7 is 21. So your final answer is 5 square root of 7 over 21. That'd be an equivalent expression as the original. It's just written with a rational denominator. Now, on the second example, the I was the bad part that's in there, and the 4 isn't bad, so you just have to multiply by the part that makes it irrational or non-real. And so in this scenario, all you really need to do is multiply by I. But before I get there, I want to take a look at this fraction, especially since it's just a one term down here. I see that I can actually reduce it. So 5 over 2i is equivalent. That's going to remove one of your steps at the end and make your work a little easier, so that's good. So you simplify or reduce first. Notice in the first example, there was nothing that we could do for that. Here now you're just going to be multiplying by I on top and bottom, so that's what we see. We have our original statement, and then we're multiplying by I on top and bottom because, again, that as a quantity is equal to 1, so it's keeping it equivalent. And then multiply the top, so 5i on top. And on bottom, you have 2i times another one, which is then I squared. And again, I squared is equal to a negative 1, so that actually makes 2 times a negative 1 or a negative 2 on bottom. We don't like to leave our negatives on bottom. Nothing else also reduces or simplifies, so you're just going to move that negative up top. So your final answer is negative 5 over 2. And that's how you simplify, or rationalize rather, the denominator of any one-term expression. Now in these two examples, we are going to continue rationalizing, but now we're going to be focusing when you have two terms. Our goal is still the same, so no negatives, no radicals, and no non-real numbers. So as you take a look at our two examples, we have 2 over 5 plus 3i. There's a complex number. And you have 8 over 6 plus square root of 2. Now that's got a radical in it, and so that's no good either. So our goal is for both of these to have our denominator be written as a real number, which does not have a radical in it. So how do we do that? As you take a look, you have 5 plus 3i. And if you recall, in a previous video, we actually did some multiplication work where we ended up multiplying and ending up with a real number as our answer. Right? So the 5 plus 3i, which is what we have here, and then we multiplied by 5 minus 3i, and that got us equal to 34. So that's what we're going to do. We're going to take your 5 plus 3i, we're going to choose something to multiply by, it's not random, that we know is going to get us a real number answer. And that's going to be the 5 minus 3i instead. And so when we multiply those, you have this 5 plus 3i here originally. Now we're multiplied by 5 minus 3i, of course, on bottom and on top. Now these are what we call a conjugate pair. A conjugate pair is when you have the same first term but an opposite second term. In this scenario, the multiplication on top is pretty simple. You just have 2 times the quantity 5 minus 3i, so that's a distributive property. And on bottom, as you take a look, you have 5 times 5, which is 25. Conjugate pairs will always have this canceling occurring, and so we can just quickly write it, especially if this is the first time we're doing it, as a positive 3i times a negative 3i, which is a negative 9i squared. And so now we know that I squared is equal to a -1. You have a negative here and a negative as a part of the I squared. That turns it into a +9 on bottom like we had before with our generic rectangle. On top, you do your distributive property, 10 minus 6i. 25 plus 9 is equal to 34. And so as we take a look at this, we see that there's one more step to do because we can simplify. A 2 goes into all of these terms, both terms in the numerator and the denominator. So you reduce, and your final answer is 5 minus 3i all over 17. Now that's what happens when you have a complex number. If you have a radical on bottom, we actually use a very similar concept. We have 6 plus the square root of 2. I want to multiply by something that gets rid of the square root of 2. Many students would think that you could just square it because that undoes a square root, or they think you just multiply by the square root of 2. But you got to be careful because if you were to square 6 plus the square root of 2, you would still have a square root in it. And if you had to multiply by a square root of 2, you would have to do the distributive property. So neither of those are going to work. So what you have to do is multiply by the conjugate. So you have 6 plus the square root of 2, same first term, so 6 minus square root of 2, opposite second term. And again, you do that on top and bottom because now this is all equal to 1, and then you proceed with your other multiplication. The numerator, you can just do distributive property, 8 times 6 minus the square root of 2. On bottom, you have the conjugate pair, so very similar canceling is going to occur, not with i's of course, but with square roots, the canceling is going to occur there. And so you have 6 times 6, which is 36, positive square root of 2 and a negative square root of 2 become a negative just a 2. And then you simplify distributive property on top, so we have 48 minus 8 square root of 2 all over 34 again. That's just coincidence. But we do notice that as we take a look at the top and bottom, a 2 goes into both terms in the numerator and the denominator, and so you reduce, and your final answer is, when you pull a 2 out of all that, 24 minus 4 root 2 all over 17. And then that would be your final answer. Again, our goal is to write the denominator so it has none of these things. 17 and 17 are exactly that. So now to summarize, if you're trying to rationalize the denominator, that means to rewrite it so that there are no negatives, no radicals, and no non-real answers. So the steps to be able to do that is first to reduce if possible, especially if you have those one-term problems. It does make it easier in the end. Take a look at the number of terms you have in the denominator. Is there 1 or 2 terms? If there's 1 term, you only have to multiply by the part that's bad, not everything. Do not think that you have to square it. Just multiply by the part that's bad, and that will make your life mathematically a lot easier. If there are 2 terms, you multiply by the conjugate, which means you have the same first term but the opposite second term. Then when you do so, you do have to be careful with your I squared, because you will have some I squareds as you've started with 1, because I squared is equal to -1, and be careful with your square roots. Make sure that you're working that correctly, and then to finish, just make sure to reduce, if possible, any common factors. And that's how you rationalize a denominator.